Aloha and welcome. In this video, we're going to talk about load balancing. So we've talked about load balancing a little bit in the past. I've mentioned how sometimes you have a very busy web server and it's a little bit overloaded. So you need to balance that out somehow so that all the burden isn't assumed by one simple server. So what you would do is you'd have two or more uh, web servers, but you would have to hand off the traffic to them in some kind of a fashion. So what you'd do is you'd use a load balancer on the front end. So a load balancer would have the IP address for your web server, and then it would take in the request and it would figure out which web server it's going to feed it to. So this is what we talked about before. A load balancer, it's a hardware device, or it could be a software program that performs the load balancing. And this is going to be happening at transport layer, which is layer 4, or the application layer, which is layer 7. The reason why you'll see it at layer 4, because a lot of people will think, well, gosh, if it's dealing with like IP address and sending it to something, you can see how it's layer 7 because it's, dealing with applications. But why is it layer, possibly considered layer 4? It has to do with layer 4 because layer 4 is where you're going to be finding the port numbers. So you're going to be using some layer 3, you're going to have IP addresses, but you're also going to have the port numbers, and it's the port number information that you're really dealing with because you're having to make decisions on, okay, it's going to this server, it needs this kind of a, application. It's a web app, so we're sending it to the web, but, what are the port numbers? And that's gotten from your layer 4 in the OSI model. So that's why it's considered both layer 4 or layer 7 device here. So this is the load balancer is going to increase your capacity because you're going to be able to expand, use more servers. So you'll be able to, carry more capacity there. You'll be able to serve more clients. It's also going to improve your reliability, your availability, and your performance. So a load balancer is going to provide an interface to the servers using what we call a virtual IP. So you'll have a virtual IP that's assigned to this device, this load balancer, and people will connect to that. So let's say it's ESPN.com. I use that example a lot, but if ESPN, let's say its IP address, and it definitely won't be this because it's a private one. Say it's 192.168.1.1. Well, you put that as your virtual IP address on your load balancer. The traffic from multiple sites or from multiple users would come in there, and then that virtual IP address, your load balancer is going to say, okay, going to hand it to server number 1 this time, or server number 2, or server number 3. So they're all coming in on this virtual IP address, and you can use different ports as well with that. So it could be, port 80 for or port 443, depending on what kind of, web traffic it's, whether it's encrypted or not. But you're going to take in the traffic through that virtual IP address. You're going to assign it to different servers according to that. There's also something called session persistence. So sometimes you will session persistence got another phrase that's used for it. It's called sticky sessions. That's the process in which a load balancer is going to direct a client request to the same server in a server group during the entire session. So if I connect to, let's say, the IRS website, I'm asking it information and everything, and it's feeding me back information. I'll stick with that one website. So every time I send a request to irs.gov or whatever, it's going to be sending me to that same one that I was using before. So that optimizes the network resource usage, and it's also going to improve the usage experience by reducing your network latency. Then we talk about the modes of operation. So load balancers, they're usually operating in one of two modes. You've got active-active or active-passive. Active-active is going to be where you've got two load balancers that are sharing the workload and distributing the traffic among the different servers. Then you've got active and passive, and that's where you have one load balancer that's going to be doing the work, and then you're going to have another one that's kind of waiting in the wings in case the first one dies. So you're going to be getting redundancy out of that. So that's going to, so the active mode, it's going to offer you more computing capacity because you're able to handle more at one time. It's going to give you redundancy with a higher cost because you got the two that are in at the same time. Then active passive, it's going to allow for uninterrupted service, and it can handle planned and unplanned service outages with less capacity than active. And then active passive, you're going to see it mostly used in disaster recovery environments. So we have four different scheduling algorithms that we can use because when we take in a request, we have to feed those out to the different servers. So how are we going to do that? Well, we can do it using one of four different algorithms here. One is the least connection load balancing. That's the scheduling algorithm in which the data traffic is going to be distributed to a server with the fewest number of active connections. So you're going to know how many active connections they have. You'll give it to the one that has the least one. Then you've got the least response time balancing, and that's going to send it to the one with the fewest active connections, but also the lowest average response time. And then we've got round robin load balancing. That's when you do it sequentially. It's like, okay, I'll do this one, I'll give to server one, next time it's server two, next time it's server three, next time it's server four, then we're starting back at server one. So you're just doing it round robin, one after the other. Then you've got IP hash load balancing, and that's where you're going to be directing traffic according to the IP address of the client. So you'll have maybe certain ones that go to this one, certain ones that go to this one, certain ones that go to this one. So you just divide it up according to the IP address. So a couple notes about this. The round robin scheduling algorithm, it's commonly used for low traffic loads, and the least response time scheduling algorithm, that's going to be used for high traffic loads because if you've got a lot of traffic, you're going to want to go with the one that's got the least, the least amount of response time necessary. And that is it for this section. If you have any questions, feel free to reach out and ask me. Again, load balancing, quick recap here. Load balancer, it's going to be taking requests in. It's going to take it in through a virtual IP address. It's going to assign it to different servers that you have in your little server farm. It can be for different ports. That's why it makes it a layer 4 protocol or a layer 7. You're also going to have the idea of session persistence. You can send it, you can take one person or one computer and send it to the same computer for the length of for the duration of that session. You've got active mode and active passive mode. You've got the four different ways of assigning it. That's going to be least connection load balancing, least response time load balancing, round robin, and IP hash load balancing. So that's it for this section. Again, if you have any questions, reach out. Aloha.